Hello, I'm John Klobuchar with InEight, and I'd like to welcome you to the latest webcast in our Best Path of Construction series. Today's webcast is titled, When Estimates Feed Work Plans, Everyone Wins. Our presenter today is Brad Barth, who is InEight's Chief Product Officer. In this role, Brad oversees product strategy and product management. His team's responsible for InEight's product roadmap and defining the company's next-generation solutions. Along with responsibility for InEight's industry advisory group, Brad and his team are actively involved with various industry associations to stay plugged in to emerging trends and market needs. If you have any questions as you watch the webcast, please email them to webcasts@innate.com, and Brad will do his best to answer them. Also, this presentation is being recorded, and we'll be sending you a link to this video in about a week's time. Once again, we're glad you've joined us. And now, let me introduce Brad Barth.
All right, thank you, John. Great to be here today with you all to talk about two topics, estimating and work planning. And we're actually not going to get into a lot of detail on either one of those topics, but we are going to explore how they support each other. And in particular, we're going to look at how a digital approach to estimating can really lay a nice foundation for you to streamline the work planning process, to be more productive in field execution, all the while minimizing your risk. And by the way, when I say digital approach to estimating, I do not mean spreadsheets. So certainly spreadsheets have been a great friend of the estimator over the years, and still a lot of things that make sense to do in a spreadsheet, but estimating major construction projects is no longer one of those. So we'll look at how modern estimating software can really facilitate a nice process for everything that comes after the estimate. So before we do that, let's back up a little bit and just take a look at our industry as a whole and one of the biggest challenges, because the topic that we're talking about today, I think, addresses this productivity problem head on. And often, you know, when we talk about the productivity problem in construction, we're talking about the field and the folks in craft roles that are actually executing the work, and how can we get them more productive. But there's also somewhat of a limit to how much improvement is available at the craft worker level and the field execution level. So there is a big opportunity in improving productivity and minimizing risk through the folks that are managing the projects, estimating the projects, scheduling the projects, planning them. And if we look back at the industry itself, you know, as a project goes from stage to stage in its journey, right? So it may start off as a concept, and there's a lot of work done to kind of scope the project and think about what are the benefits of that project. And then as that gets handed off, we're going into the next stage, and we're going to get a designer involved or an engineer involved. And there's a whole handoff that happens there, and we kind of take a step back, and then as that design work happens and we build up all of the information in that stage, then it goes to construction, and then we go to startup and we go into operations. And at each stage, there's this very non-productive handoff that results in knowledge loss, it results in rework, it results in redundant effort. And that same thing happens whether we're going from stage to stage, but the same thing happens as we go from stakeholder to stakeholder, right? So as we go from the owner to the engineer or architect to the contractor to the subcontractor to suppliers, we have the same type of non-productive work that happens along the way. And then even within one of those stakeholders, let's take the contractor stakeholder, going from function to function or role to role within the contractor results in that same drop off every step of the way, right? As we hand off from estimating to scheduling to work planning and so forth. So there's a big opportunity there to improve that handoff process with a digital approach. And that digital approach can really eliminate that, you know, 2 steps forward, 1 step back approach that we often see. And that creates a great opportunity to improve productivity, not necessarily at the craft worker level out in the field, but with all the folks that are managing the projects and overseeing those projects as they go through their life cycle. So there's a big opportunity for improvement there from a productivity perspective. which might be 15% or more. And depending on where your projects are at and the sort of maturity of your business process, it might even be significantly more than 15%. This is probably more like what we often see at InEight as we go out and engage with customers. There's a tremendous opportunity to get a lot more productive as projects go from estimate all the way out to the moment when foremen are turning in time at the end of the shift and recording quantities. So the estimate is the beginning of that journey, right? Particularly for the contractor, we will typically get involved when it's time to create that estimate. And regardless of how we're doing that, right, there's a lot of thought and analysis that goes into that process. So we're looking at the drawings, we're looking at the specs, we're doing site visits, satellite images, everything that we can get our hands on to really understand the scope of the work, site conditions, what are the risks, what kind of resources do we need, all of that kind of information we're thinking through as we do our job in estimating, right? So we capture all that information into the estimate itself, which is certainly valuable in the sense of creating the estimate. But there's a lot of other benefit to creating that information, and that goes to what happens after the estimate. There's all kinds of other things, and some of this might start even before the estimate is done or before the project is awarded, but we're probably going to have to create some schedules at some point. That's going to need durations. It's going to need costs and resources if we have to produce a cost or resource loaded schedule. We're going to certainly have to plan out the work. And that means we need to really understand the scope and what are the quantities of the work, what are the man hours we're expecting. We've got to make sure everything is procured. And if there's engineering work, fabrication work, we need to make sure that's been done properly. And for that, we need the bill of materials, right? What's the stuff that we need to install as part of the project? And then certainly field execution, right? We've got to ultimately build the work that's required as part of the project. And we want to be able to do that against the cost that's been budgeted and against the productivity goals. And really all of that information, if you think about it, starts back in the estimate, right? So this is the premise here. If we can take that information and capture it in a logical fashion through a digital approach to estimating, all of these other functions become a lot easier. And that's what we're going to take a look at next. So let's think a little bit about what's happened over the last 10 or 20 years in other industries. Certainly we're all familiar with what's happened in engineering and design as those professions have moved from a 2D approach to a 3D approach. Today, pretty much everything we see that's gone through an engineer or designer has been done in a 3D model, meaning, if you look at that building there, those windows are not pixels. They're not drawn, right? They're not laid out in a 2D format. They're actual objects that get assembled together, whether it's the steel or the glass or the concrete. It's all of those things are objects, right? Which kind of get assembled together to make that 3D model that we're looking at. Same kind of thing. Another great example of that is just in game development. So totally unrelated industry, but when you look at the games that are created today that have these amazing interactivity, everything you see in those games are objects, right? They have properties. They know what happens when they come in contact with each other. They know how to interact with each other. Every single potential interaction does not have to be scripted. What you do instead is you create objects that have properties, and those properties know how to behave in every situation that the game player might run into. And so we can think of estimating the same way. Ideally, we're going to create our estimates using those same sort of objects that have properties and objects that have some smarts so that when you assemble them together, they know what to do in order to create a proper estimate. Here's an example of an object-oriented approach to estimating, right? This is what we would call a cost item assembly. And what you can do with these assemblies is, what we're trying to do in this case really is come up with an estimate, let's say, for a retaining wall with certain specs, certain dimensions. Certainly we could do that in a spreadsheet. and put in the costs, put in different variables that drive the cost. But what the approach is that will facilitate everything that comes after estimating is to use this object-oriented approach, right? So using these intelligent models or intelligent assemblies, the estimator can go in and put in different inputs, right? So we can put in, in this case, what's the length, what's the wall thickness, what's the material specification, answer yes, no questions, all kinds of things that can walk us through, what is the object that we're trying to create here? What are the properties of the object we're trying to create? And when we answer the questions, it's creating the estimate for us down below, right? So it's broken out. If we're going to do that retaining wall, it knows we've got to buy some materials. It knows that we've got to do the footings. It knows that we've got to build the wall itself. And then even some of those things, we've got to do some sub-steps, right? We've got to form the footings, pour them, strip them. So this detail level estimating, in the past would take a lot of time and a lot of formulas and really create a lot of risk to do that level of detail in a spreadsheet. It's not impossible to do, but it's not for the faint of heart either. So here, by using this object-oriented approach, we're creating details that can be passed on to the next person in the chain, whether that person is creating a schedule, creating a work plan, buying the materials, etc. So, we can drill in, for example, if we wanted to see, okay, what objects, if you will, or what components drive that form footing, I can drill into that and see, oh, well, we've got a concrete crew, and based on the inputs that we put in up above, it knows how many hours that crew is going to need to work and how much is it going to cost. And then I can further drill down into, well, what's in that concrete crew? Well, it's made up of different laborers. They're, depending on the nature of the work, it might be equipment in that crew. Really, those individual resources, right, are what make up that, ultimately what make up that crew, which makes up that particular component of forming the footing, which then rolls all the way up to the retaining wall itself. And the beauty of that is that each of those individual things, so for example, that laborer there, that carpenter that's going to help us with the forming, it's got properties associated with it. It knows what the rate is. The digital approach allows us to easily make adjustments as needed. We can easily pull this same assembly into a project in a different part of the country, and it knows that the rate would need to change in order to reflect the appropriate rate for a carpenter in that part of the world. If there are certain conditions that we specify up above that might affect the productivity of that crew, that would automatically give us a new set of man hours. Okay, so this object-oriented approach certainly results in the same thing that the spreadsheets that you may be using today for estimating do, which is it's going to give me a cost and it's going to give me some man hours. But by creating this component level or object-oriented model, that gives us the ability to easily make adjustments, and most importantly, it gives us the ability to validate our assumptions once we get into work planning and field execution, right? So if we end up not hitting our budget or our duration, our schedule for this particular task, we'll be able to know, well, why was that? Did we go over budget because we took longer than we expected? Was it because we used more expensive resources than we thought we would? Was it because our crew productivity wasn't what we thought it would be? Was it due to change orders? All of those things can be answered along the way, and then that gives us more knowledge that we can use the next time we're estimating. So when we use that kind of an approach, as I mentioned earlier, that really facilitates these other functions that happen after estimating. And because those models and those assemblies are so have so much intelligence baked into them, you can create those sort of object-oriented detail level estimates just as fast as you could using a traditional spreadsheet approach. But again, the benefit is that now all of that information can flow smoothly into these other functions. And that way, when they get a hold of them, right, when our schedulers get a hold of them, we may be awarded a project and 3 months later or 6 months later, whatever it is, the work begins. things may have changed since then, so we need to go in and make some changes to those underlying assumptions. That becomes really easy to do when we've got that object-oriented model to work with. So let's focus particularly on work planning now. So as we think about, how are we going to go execute that work? What do our work packages look like? How are we going to push this work out in the field? How are we going to employ our crews and what sequence and so forth? So to do that, obviously, we need to know what's the scope of the work. We need to know the quantities of the work. Ideally, we know, what are kind of the man-hour assumptions, and a much longer list too, right? We could list out here all the other things we would ideally have at our fingertips, and a digital approach makes those things accessible, things like resource requirements, productivities, and so forth. All right, so let's focus here on what happens after estimating in the context of work planning. So maybe even let's talk about just work packaging and work planning in general. Where does that kind of fit in the life cycle of the project? The Construction Owners Association has a nice definition here. Construction work packages provide integration between estimating, field engineering, safety, project controls, and materials management. No surprise there. But that first bit there, estimating, right? This is the information that we've just been talking about that we want to pull into the work planning process. We don't want to start over when it's time to hand off to the field and the folks, the field engineers, project engineers that are going to be planning the work. They should be picking up where estimating left off. And when we think about work planning and some of the best practices that come into play there, certainly there are a number of them. AWP, Advanced Work Packaging, is one approach that's really getting a lot of traction in our industry for lots of very good reasons. But it's really a best practices based approach that really just calls for breaking down the work into manageable chunks that can be executed without constraints in order to make the crews as productive as possible. So we think about what these levels of detail are here. When we get into work planning, when we're creating work packages, those are logical, manageable divisions of work within the scope of construction. Right? That's a pretty simple definition of it, coming in this case from the AWP Institute. When we get down into IWPs or installation work packages, this is ultimately a scope of work that we can push out to the field in order to start divvying up into daily plans, right? So what's the difference between an installation work package and a daily plan? Installation work packages are typically about a week's worth of work, sometimes 2 weeks, depending on the nature of the work and the overall length of the project. But it's a scope of work that is ready to execute, right? There's nothing dependent. We're not waiting on anything. The crews in the field will have everything they need to go do that work. Daily plans, on the other hand, represent about a shift's worth of work, right? Or a day's worth of work. So this is the domain of the foreman, and this is where we're going to be looking at specific crew assignments, doing a shift's worth of work. There's a concept of short interval planning that comes into play really in between those two levels there, right? Between the installation work packages and the daily plans, and really ties that together with the schedule. So here, using InEight schedule as a backdrop, you can kind of see our overall schedule for the work. And then at a certain level, as we drill down into that, usually about level 3 in the schedule, we'll get down to those installation work packages. And then we can start to break those up into daily plans that we're going to assign out to the crews. And one of the great things that a digital approach and a technology approach to short interval planning can lend to us, compared to, say, a grease board or whiteboard where we're doing things sort of the old-fashioned way. Here we have the ability to look at that blue bar there. Tells us kind of what's the start and finish date according to the schedule that we need to meet. So as we start planning out the work and divvying it up to the different crews and different subcontractors, we're doing everything we can to stay within that start and finish duration that's provided by the schedule. Sometimes we won't be able to do that, as you can see here down in this case, down in this backfill section as we've broken up that work to the different crews. Maybe we had a day where we weren't able to do work for whatever reason, and so we had to push some of that work. And ultimately, you can see there, that's why it's highlighted in orange, we're outside of our schedule that we originally were trying to meet. So rather than doing that in kind of a disconnected approach up on the whiteboard, we do it digitally, leveraging the information that started in the estimate in terms of what resources do we need, what productivities do we expect, and what are the man hours and so forth. All that information comes into this planning process so that as we start moving bits around on this schedule, we know what the assumptions are, we know whether it's possible to get that work done within the time constraints that we're trying to hit. And if not, we may need to update the schedule. From there, we can get into, again, using InEight's tools as a backdrop here as we get into our work planning capability. What we can start to do as a best practice is to break that work down into daily plans that do get pushed out to the field for execution. And that's really a two-way street, right? We're gonna facilitate the information flow so that we're not starting over, right? When it's time for the foreman to go execute that work, that foreman should have everything that he or she needs to go execute the work. What's the scope of the work? What's the budget item we're trying to hit? In this case, you can see that one budget line item there, that retaining wall, that originated in the estimate, right? We could trace that all the way back to the estimate and see what were the assumptions the estimator made for that retaining wall. And here we've taken, a small chunk of that to make part of this daily plan, right? We're gonna plan to accomplish 39.5 cubic yards. It's gonna take us 30 man hours, and the budget, again, that came from the estimate was 36 man hours to accomplish that. So if we hit our plan, we're gonna be ahead of budget. So these daily plans not only have the scope of the work and give us all the assumptions that we need as a foreman to go execute the work, but there's also all kinds of other information we can include in here using this digital approach, right? And the foreman could bring this up on a tablet or a laptop and have all of this right at his or her fingertips. So safety information, quality information. And then certainly the two-way street that I reference is not just, hey, show me all the information that I need to go accomplish the work, but at the end of the shift, I'm going to provide that validation that is useful back in estimating, right? So as we go full circle, we're going to want to know, hey, the assumptions that I had in that estimate, how did those play out? Were we able to accomplish the work, according to what we had estimated? And all those assumptions, that object level detail, this is where the rubber meets the road, right? So at the end of the shift, we're turning in what kinds of resources did we actually use? How many of them did we use? How long did they work? And then ultimately, what quantity of work did we get done, right? So once we know that, and again, this is another example where, doing this, we have to do this anyway, right? We need to capture timesheet information to drive payroll. We need to capture quantity information to drive billings and earn values, right? So, but if we can do that in a way that not only accomplishes those things, but also creates that full digital circle back to estimating, so that the next time we're estimating a similar scope of work, we can reference, this time and every other time we've ever done that to know, hey, what productivity should we expect? Okay. So these budgeted quantities, you can see here in this case, we had a planned quantity of work that we were going to accomplish to achieve that 39.5 cubic yards to drive our earned values. What we actually installed in this case amounts to, as it goes through these earnings rules and weighted values, amounts to about 41.5. So we beat our plan, right? Well, did we accomplish more quantity, but maybe we spent a lot more man hours? Well, that's something we're going to want to know, right? So this productivity tab, and again, this is the exact kind of information that's useful not only in showing how we're doing against the work, but also validating those estimating assumptions. So foreman, you want them to get that instant feedback, right? At the end of the shift, we turn in our time, we turn in our quantities. how did we do for the day? What's our gain loss against the plan? Right. So in this case, you can see we had a budget of 0.9 man hours per unit. That was what's in the budget. That started all the way back. You can trace that all the way back to the estimate. Our plan was to do better than that. And then what we actually did was even better than that, right? So based on the productivity we achieved with the crew that day, we came in below budget and even below what the plan was going into the day. So not only do our foremen get that instant feedback, so we know, hey, should we, if this was in the red instead of the green, do we need to think about changing our approach to the work, changing our crew configuration, changing equipment? But again, at the very least, as we're tracking that information, it becomes part of that measuring stick, right? We know how we're doing against the budget, and we're building up that knowledge library. Every time we accomplish some work at the end of every day, we're building up that knowledge library that's going to be useful on every future project. That's one of the benefits of that whole digital approach. Very difficult to accomplish that same sort of thing in a spreadsheet. So how does that come back into play as we track that detail level performance out in the field? We mentioned that's a two-way street, right? So capturing that information in an all digital approach enables it to come back so that in estimating, now we're estimating the next project, right? And we're estimating, let's say in this case, excavation, but in this case, it's excavation, but it could be anything, right? Could be steel, concrete, what have you, right? Piping, whatever the line items are, whatever the scope is, every time we go execute that out in the field, we should be creating data points. That's what you're seeing in this chart, so that the next time we're estimating it, in this case, 45,000 cubic yards of excavation, we can go in and tell the system, give me relevant projects that have involved that same scope of work, maybe from the last couple of years, maybe from the same geographic area with similar profiles. And that's showing us these data points now so that when we're estimating it, you can see our current estimate is that white diamond there. How have our historical projects compared to my current estimate, right? That gold square there represents the average of those 5 data points, those 5 other projects. And I can see my current estimate is just a little bit below that average. So this is the main benefit of that all digital approach, and that digital approach that starts with that object-oriented estimating down to that component level, because when we get that information back, when it goes through the cycle, we've executed the work, we've built up, we've captured the performance of what actually happened. Now when we're estimating the next one, we have a lot less risk in terms of we can kind of look at the crew that we're using. How does that compare to these other data points if we wanted to drill into them? How does our productivity compare? And certainly you're not going to do that analysis on every line item in the estimate. But if you apply the 80-20 rule, let's take the 20% of the line items that represent maybe the 80% of the value or 80% of the risk, and do this sort of analysis. We can save ourselves either a lot of time if you're trying to do this manually now using 3-ring binders or Excel spreadsheets. We can save you a ton of time doing that if you go to this all digital approach, but also a lot of risk, right? So which can turn into not just incremental improvements on your projects, but can keep you out of multi-million-dollar troubles on projects where we didn't account for the right risk. So this kind of brings it full circle, right? This brings us all the way back to estimating. We've got that knowledge library, all those data points that we can reference to make sure our future estimates are more accurate. And it also helps us scale the business, right? So we don't have to have intimate knowledge or firsthand knowledge of all of these projects that happened in the past in order to leverage them during estimating. We don't even have to be an expert in estimating that particular scope of work in order to get a good, reasonable number we can use all of that work that the good people before us have done to capture that knowledge and make us smarter as we go through the process every cycle. So to recap, the goal of this session was to talk about how proper estimates and that digital approach to estimating can enable better work planning, and that full circle digital approach really drives the types of benefits that I think we all want to achieve, right? So if we create those object-oriented estimates, you're not going to spend any more time creating those than you do today using your spreadsheets, and probably you're going to spend less time. Certainly as you get into bid reviews and collaboration amongst estimators, this approach makes that a lot easier than trying to interpret everybody's spreadsheets and the formulas that are in them. And then that information flows into things like work planning, where we've already got information that can facilitate creating those work plans, pushing that information out to the field, getting it into our foreman's hands in order to have a measuring stick to track those actuals against. And then once that work is executed, we're tracking the results in our knowledge library so that we can benchmark our future estimates using that real-world actual performance. Really, these are just best practices, right, that we're probably all trying to do already in one way or the other. But I would propose to you that a digital solution like what InEight provides can help you get there a lot faster and help your folks execute in a more standardized way, in a more consistent way. And that's not only going to result in better performance on each project, but it's going to position your company to better handle growth, to better handle new opportunities, and not get bogged down in the fact that maybe a lot of the deep knowledge might be tied up in a few individuals' heads. Ideally, what we're doing here is capturing that knowledge in a way that can be reused project to project, person to person, role to role, and that's going to make everybody happy, make all of your projects in your company more successful. So I would encourage you, if you want to learn more, visit InEight.com. Thanks for your time today.
Thank you, Brad. Again, if you have any questions about today's webcast, please email them to webcasts@InEight.com. To learn more about InEight, as well as our solutions that get you on your best path of construction, visit InEight.com and click on the Request a Demo button. And if you'd like to see a schedule of upcoming webcasts, visit InEight.com/webcasts. Thanks for watching. This concludes our presentation.